Hello, everyone. Uh, my name is Teresa. I would like to welcome you at our Revolgy webinar. It's called Optimization of Kubernetes Workloads and Cost. Uh, I'm just a introducer here, but the main speakers will be George and Theo. They are from operations team, and I will just give you the mic, Theo.
Hello everyone, my name is Theo. I'm at Revolgy for the past 3.5 years. I'm at the moment a cloud operations engineer here at Revolgy, focused on AWS and GCP.
And hello, everybody. My name is Georgios, or you can call me George. I'm part of Revolgy team since 2018, currently working as SRE position and focus more on our team processes, monitoring, and clients infrastructure. Welcome, everybody. So let's start quickly with the agenda. We are going to discuss about how to optimize Kubernetes workflows and cost and performance. Revolgy's approach is the first topic that we are going to discuss, and the main thing that we are going to try to share here, where we are going to help you identify the nature and criticality of different tasks, techniques of replication scaling and resource allocation, utilizing various instance provisioning types such as on-demand, spot, and reserve instances to reduce expenses. And as a last step, we are going to take an introduction on some of the tools available like Carpenter, Keda, and Autoscaling Group. Theo.
Thank you, George, for introducing the agenda. Let's start actually by emphasizing a $1 million question, which can save you even more than $1 million if the correct answer is chosen. Imagine you are working for a tech startup called Cloud Innovators INC, and you are tasked with optimizing cloud operations. Your mission is to maximize efficiency and minimize costs. How would you tackle that? Let's check our options. We can start with a delete everything strategy. You can delete the whole workload running in the Kubernetes cluster, and suddenly everything will become super duper optimized. We also have the monkey method. You can hire a monkey to randomly start pushing buttons in the cloud console. Even in this way, there is a slight chance somewhere there that things can become efficient and optimized on first try. Moreover, there is an option to blindly start following the best practices that I described by each cloud provider without actually evaluating how they can apply it to your specific needs. Lastly, we have the Revolgy approach. Using the Revolgy strategic insights and tools, it's doable to tailor a cloud management solution that will actually fit your company's unique workload needs. It's important to mention also that no monkeys or blindfolds are required in this case. This is actually where we will dive deeper into it today. Let's move on and have a quick overview of the sections that we will go through today.
Thank you, Theo. Thanks for answering that $1 million question right. So let's have a brief overview of the approach to simplify complex cloud operations. The first one, and one of the main parts of the Revolgy approach, is identification of the nature and criticality of different tasks and the workloads that runs on Kubernetes cluster. As we will see in a bit, different criticalities and natures require different handling. Also, we will discuss about how we are using different techniques for replication, scaling, and resource allocation. Next, as we already mentioned in the agenda, we will talk about the use of various instance provisioning types, such as on-demand, spot, reserve instances, with ultimate goal being to reduce expenses efficiently without ideally causing any impact. Lastly, we will take a quick look at some tools that we are using at Revolgy in order to make our scaling process efficient, cost-effective, smart, and dynamic. The tools we are going to check are Keda, Carpenter, and Autoscaling Groups. Now, let's deep dive into these key pillars, beginning with the importance of understanding the nature and criticality of our workloads.
Thank you, George. So let's start with the first topic, which is the identification of the nature and the criticality of the workload. In fact, we will split that into two pieces, with the criticality of the workload being the first one. As we can see, we are dividing the workload in three main categories. The high criticality tasks are essential for core business functions, directly impacting revenue and customer satisfaction. For instance, think of a customer transactions on an e-commerce site. If these tasks fail, it leads to immediate loss of sales and potential damage to the brand's reputation. To ensure their reliability, we must prioritize high availability, redundancy, and disaster recovery measures. Then we have the medium criticality. These tasks support important business operations but are not directly tied to immediate revenue. An example would be an internal communication tool. If this system experiences delays, it can hinder productivity but doesn't necessarily stop core business activities. For these tasks, auto-scaling to manage resource allocation and implementing moderate monitoring can provide a very good balance between performance and cost. Lastly, we have the low criticality. These are non-essential tasks that can tolerate delays and service disruptions. Some examples may include, for instance, development environments or batch processing for data analytics. Since these tasks aren't very time sensitive, they can offer opportunities for cost savings by using more cost effective and cost efficient instances, such as the spot instances, or scheduling that part or that kind of the workload outside the peak hours. Now, my colleague George will elaborate more on the categorization based on the nature of the workload.
Thanks, Tio. Explaining the criticality of workloads is a rather important aspect of understanding your workloads. Now, let's discuss another equally important classification of workloads based on their nature. There are several ways to classify your workload, including CPU, memory, or GPU intensive. Let's start with CPU intensive. CPU intensive tasks are tasks that require significant computational power to perform complex calculation and process large volumes of data quickly. Such tasks could be scientific simulations, real-time data processing, and financial modeling. Memory-intensive tasks are tasks which needs substantial memory capacity to store and process large data sets or manage extensive in-memory operations. An example of such cases is big data analytics, caching services, or in-memory databases. Lastly, GPU-intensive tasks are tasks which have high graphical processing power, which typically handling complex computations and rendering tasks. Those tasks include machine learning, model, 3D rendering, or video encoding. To better understand these classifications, we would like to offer you a real-world example of CPU-intensive workload. Imagine an e-commerce website during a major sales event, for example, Black Friday. During such events, the website experiences a massive spike in traffic as users browse and make purchases. This requires significant computational power to handle the increased load and ensure smooth and quick processing of the user requests. For such applications, we would configure Kubernetes to use horizontal pod autoscaling (HPA), ensuring that more pods are added during peak times when traffic spikes. Additionally, we can set high CPU requests and limits to guarantee each pod has enough computational power to maintain optimal performance. In conclusion, understanding the nature of your workflow, whether it's CPU, memory, or GPU intensive, you can make informative decisions about resource allocation, scaling, and optimization. This ensures high performance, cost efficiency, and reliability of your applications. Having that said, let's move to our next session where we will discuss techniques for replication, scaling, and resource allocation. These techniques ensures that our applications are highly available, efficiently scaled, and optimally utilizing resources. Let's see some of those. To begin with, we have replica sets, which are used for highly available applications. Replica sets ensures the desired number of pods are always running, contributing to application stability. Next, deployments, which manage the lifecycle and scaling of applications, ensuring consistent and reliable updates. For stateful set applications, we can use stateful set objects, which provide stable identities and persistent storage. They ensure ordered deployment and scaling, which is crucial for applications like databases. Next, horizontal pod autoscaling, or HPA, which adapts to demand, maintaining performance by scaling the pods based on metrics like CPU, memory, or custom metrics. Vertical pod autoscaling, VPA, optimizes resources usage by adjusting pod resources based on actual usage. It's ideal for applications with dynamic resource needs. I would like to offer you here a tip based on our experience. In order to make vertical pod autoscaling and horizontal pod autoscaling to work together efficiently, they will need to be properly configured in order to avoid conflicts. So one recommendation here would be to run the vertical pod autoscaling VPA in recommended mode rather than update mode. Continuing on, resource quotas prevent resource exhaustion and help you budgeting and cost control by limiting resources per namespace. And lastly, quality of service prioritize critical workloads, ensuring that they receive the necessary resources while allowing less critical workloads to use resources opportunistically. Let's check our previous example of the e-commerce website during a major sales event like Black Friday. As we mentioned, we are going to use deployment in order to manage the life cycle of the application and ensure that the desired number of pods are running consistently. By configuring requests and limits, we apply quality of service and categorize the pods and define the priority as we're setting them to guarantee for critical workloads. Furthermore, we can implement HPA, or horizontal pod autoscaling, to scale the number of pods based on real-time CPU usage, maintaining performance during traffic spikes. This will ensure that as the user activity will increase, our application will scale seamlessly to handle the additional load, providing smooth experience and preventing performance degradation. Now, understanding those techniques and workloads for optimizing Kubernetes performance is crucial. This is the foundation and it's essential as we move forward with the next topic. Where will we explore how different instances provisioning types can help reduce the expenses further.
Thank you, George, for the deep dive. So now we will talk about the three main categories of types of instances. It's important to mention that certain cloud providers might have some additional options available, but the core idea remains the same though. First of all, we have the on-demand instances. These offer the highest flexibility with no long-term commitment. In plain words, you are going to pay for compute capacity by the hour or second, and you can increase or decrease your compute capacity depending on the needs of your workload. This makes on-demand instances ideal for short-term workloads with unpredictable scaling and event-driven workloads that cannot tolerate service disruptions. However, we should have in mind that this flexibility comes at the highest cost. Secondly, as we can see here on the slide, we have the spot instances. The spot instances could allow you to take advantage of the unused capacity of the cloud provider at a reduced cost. Sometimes that reduced cost can be even up to 90% off compared to the on-demand prices. The trade-off, though, is that the spot instances can be terminated with little notice if the capacity is needed elsewhere. They are best suited for batch processing, data analysis, and in general, fault-tolerant workloads that can withstand interruptions. Using spot instances can lead to significant cost savings if your workload is designed to handle interactions gracefully. As the last option today, we are going to discuss about the reserved instances. Reserved instances offer significant discounts, even up to 75%, in exchange for a commitment to use a specific instance type in a particular region or zone based on the cloud provider for either 1 or a 3-year commitment. These are ideal for steady state and predictable workloads where you can commit to a long-term usage. By planning your capacity needs and using reserved instances, you can achieve substantial cost savings, while at the same time you can ensure that your critical applications can have the required resources whenever they need them. Since we have described the 3 main types, let's bring this to life with an example in order to make it a little bit more clear. Imagine you have been running, for example, a database in a managed Kubernetes cluster on AWS for the past 2 years. This database is currently using 3 on-demand instances spread across 3 availability zones. The load on the database is stable for the past 2 years and is actually expected to remain the same for the next year or so. Given the predictability and the stability of this workload, continuing to use on-demand instances is not a very cost-effective solution. The ideal choice here would be to switch to reserved instances. That's because by committing to a 1-year or a 3-year term based on what the expectations are, you can significantly reduce your expenses, as mentioned before, potentially saving even up to 75% compared to the on-demand pricing. This approach not only cuts costs, but also ensures that your database will be able to continue to have all the necessary resources it needs without the variability in pricing. Each of the aforementioned types, though, comes with some pros and cons, like everything else on this earth, right? So, George, would you like to elaborate more on the pros and cons of the different instance types?
Sure. Let's summarize the different instance provisioning types by examining their pros and cons. Understanding this will help you choose the best option for optimizing both cost and performance in your Kubernetes workloads. So let's start with on-demand. On-demand provides no long-term commitment. It's easy to scale up and down as needed, and it's consistent and reliable performance-wise. On the other side, it's more expensive in comparison to spot and reserve instances, as you have the pay-as-you-go model. Spot instances, on the other side, they are significantly cheaper than on-demand, as T already demonstrated. And it's great for jobs that handles interruptions, and they are ideal for fault-tolerant workloads. But the instances can be terminated, so they are unpredictable. They're quite complex since they requires robust fault tolerance and handling logic, and the availability of the machine types that you need might be limited. Lastly, reserve instances. You can save up to 75%, as T already mentioned, in comparison to on-demand. They ensure the availability for critical applications, and they have fixed pricing for the term of the reservation. But the commitment requires 2 or 3 years. So you have to know about your workloads, and for that specific reason, They are not flexible because they are not suitable for short-term, and unpredictable workloads. In conclusion, each instance type has its own advantages and disadvantages. Your choice will depend on specific needs of your workflows, your budget, and your flexibility requirements. On-demand instances offer flexibility. Spot instances provide cost savings for fault-tolerant workloads, and reserve instances offer cost savings and guarantee capacity for predictable workloads. Now, we have identified the best provisioning instance types for different scenarios. The next step is to ensure that Kubernetes environment can effectively scale these instances to meet the demand. This is where tools like KEDA, Carpenter, and Autoscaling Group comes into play. To elaborate more on those tools, I will hand it over to Theo. Theo, can you tell us more about those tools?
Sure thing, George. Thank you. As it was already mentioned, at Revolgy, we are utilizing three main and very important tools in order to optimize workloads within Kubernetes environments. These tools are Carpenter, KEDA, and the Autoscaling groups. Each of these tools bring unique capabilities tailored to different scaling needs and environments. We are actually going to go through them in a nutshell today, just to explain a little bit more how we are going to use them in more practical examples and how we are currently using them here at Revolgy. Starting with Carpenter, this modern tool is designed to react rapidly to changes in workload demands. Carpenter is capable of ensuring efficient resource use and cost savings by dynamically adjusting the number of types of instances in real time, or usually almost in real time, within a couple of seconds. This is particularly beneficial when you need to provision resources quickly, reducing overhead and enhancing performance. For example, think of a scenario where there is a high-demand workload, and Carpenter is capable of launching additional nodes within seconds, ensuring that your applications have the necessary resources whenever they need them. Next, as we can see here, another very important tool that we are using at Revolgy is KEDA, or the Kubernetes Event-Driven Autoscaling, which is its full name. KEDA scales applications in response to events rather than additional or traditional metrics. This is ideal for workloads that need to scale based on the rate of events they process. With its support for multiple event sources, KEDA is capable of allowing developers to define scaling rules that are both dynamic and event responsive. This can ensure that applications can handle fluctuations in demand without over-provisioning resources ahead of time. A very common use case, I would say, for KEDA is dynamic scaling based on the number of messages, for example, being added to a queue, such as an SQS queue on AWS. Lastly, we have the Autoscaling group. The name is usually pretty much the same across all major cloud providers, such as GCP or AWS. The Autoscaling groups are crucial for maintaining application reliability and performance. Their monitors are usually capable of monitoring applications and automatically adjusting capacity in order to maintain a steady and predictable performance at the lowest possible cost. They are particularly useful in environments with predictable variation in load. For example, think of a customer with peak hours in their workload, which might need to ensure that they have enough resources during these times. In that case, by leveraging scheduled scaling, the Autoscaling groups can proactively scale out resources before those peak hours, which can ensure the high availability and the ultimate performance, which is the ultimate goal here. Based on that, to illustrate this concept, I will also mention, let's say, a world-real example that we have experienced here at Revolgy. One of our customers experiences certain peak hours during which they require substantial GPU resources due to some very GPU-intensive workloads related to some machine learning tasks, which is a very hot topic actually nowadays. During the peak hours, it's crucial to have sufficient GPU instances to meet the demand. However, GPU instances are often scarce and may not be available for scaling on short notice. To address this, what we have done here at Revolgy is that we are proactively scaling out the number of instances using the AWS native feature of auto-scaling groups. This approach avoids unnecessary complexity, while at the same time, we are capable of ensuring the resource availability and the cost efficiency. In summary, these tools exemplify the advancements in automated scaling technologies. They can ensure that Kubernetes environments are more responsive, cost-efficient, and reliable. These are the core points of the Revolt's approach in optimizing the workload in order to ultimately reduce costs while optimizing performance. Let's summarize and check out the main key takeaways from today.
So, in conclusion, optimizing cost and performance in Kubernetes workloads is going to be an ongoing and dynamic process. Your infrastructure is like a living organism, as we like to say here in Revolgi, that requires constant attention and adaptation. By understanding the criticality and the nature of your workloads, you can make informative, data-driven decisions about resource allocation. Implementing techniques for replication, scaling, and resource allocation alongside with selecting the appropriate instance provisioning types helps balance cost, efficiency, and performance. Tools like Carpenter, Keda, auto-scaling groups adds the flexibility and responsiveness needed for effective Kubernetes management. Lastly, remember maintaining simplicity and avoid unnecessary complexity where essential for efficient and manageable cloud operations. Thank you all for joining us today, and we will hope that this insight will help you successfully optimize your Kubernetes workloads. Teresa, we are back to you.
So thank you very much for all information you just provided. It was great. So now let me check the comments and questions. Expressing yes. So here is the question. Can you explain reserve instance pricings? Do we have to pay the full amount for the entire 3-year period upfront?
Maybe I can take that question actually. Great question. Well, that really depends on the different AWS, on the different cloud providers, because certain cloud providers have different actually, I would say, options for paying for the reserved instances. Usually, the three main, let's say, ways for paying for reserved instances is full upfront, partial upfront, and no upfront. No upfront means that you don't pay any amount ahead of time, and the full cost is split across the whole, let's say, reservation period of time. Partial upfront is that you pay part of the cost of the whole reservation in the beginning, and then the rest of the amount gets split across the rest, let's say, months or different time frames. And lastly, the full upfront is that you pay everything when you purchase the reservation, and there is no, let's say, additional charges being created during the reservation. The thing is that usually the higher the upfront payment is, the better the terms are and the higher the discount is. So if there is, let's say, possibility and it won't affect the cash flow or anything like that, then paying usually full upfront is the best choice, as it will reduce the total cost at its the most, I would say. Hope this answers the question.
Thank you. So we have another one. How do spot instances signal termination to the running workloads, and how should we handle this in Kubernetes?
Would you like to take it, or should I?
Feel free, George.
All right. So Well, thank you for the question. It's actually a great question. The use of spot instances, as mentioned before, is a cost-effective way to use unused cloud capacity, as we already established. But they can be terminated by the cloud provider with little to short notice when the capacity is needed elsewhere. This little notice vary based on the cloud providers. And it's actually translated into a couple of minutes mostly, but it's not like a specific time. Ideally, the workload running this kind of instances on these instances should be handled gracefully by the terminations. However, we would like to suggest to use some helpers that can be deployed on Kubernetes cluster in order to handle those cases. There's an example on AWS. You can use a daemon set that can be deployed to handle terminations by monitoring and acting according to the events that appear. To be honest, I don't remember that on the top of my head, but maybe we can follow it up later. I'm hoping that this will answer your question.
You're muted.
Yes, we will send all slides and questions and answers after the webinar, so you will have access for it, and you can maybe deep dive a little bit more. We also have one more. Can you elaborate on how to implement off-peak scheduling?
I can take that because it's something that I would really like to put into the presentation. Well, if I understand correctly, the question, and it's actually a great example here and great question. Thanks for providing that. You are referring to scheduling something like a small tasks on Kubernetes. So if I understand correctly, the question, the answer would be to utilize job objects on Kubernetes, which are simply running simple tasks. And with cron jobs, you can manage those jobs to be executed on a timely based schedule. So off, as the question is asking, off business hours or off peak hours. An example of that workload, some of our clients are doing maintenance tasks, data backups, and sometimes like report generations. And all of them are running outside their core business hours, usually during the night. And all of those workloads are running on spot instances as well. So keep in mind that as we establish understanding your workload, nature and criticality, by understanding that this is not a major critical task that can be interrupted, it's best to be scheduled on a spot instance. I'm hoping that this answers your question.
Teresa, you're muted again.
Yes, thank you very much. There is also one more question. David is asking if there will be recording of today's session. David, yes, it will be. It will stay on YouTube and also on LinkedIn. So you will have the access to it for forever, probably. So in case we don't have any other question, I'm checking and probably not. So let's wrap it up. Thank you, George and Theo, for your time today, for the information provided. I found it very useful, and even I'm not from the technical team. As I said, we will share slides and some feedback form after the webinar today afternoon or early tomorrow, so you can give us some feedback, maybe note some topics for the next webinars. And just a little bit about Revelgy, so you know who we actually are. We are all about making the cloud work for you. We specialize in helping businesses worldwide optimize their cloud stack, especially with the Google Cloud and AWS. It doesn't really matter if you are a startup or traditional business. We can help you with all cloud stuff. We also have a managed service portfolio. We work with the people like George and Theo, so they ensure your cloud operations are running smoothly and you can succeed with your business faster and cheaper than your competitors. All I said is on our website. You can check it. It's rebelg.com. And I think that's it. So thank you very much, Theo and George, again. And I hope to see you soon for the next webinar.
Thank you, everybody.
Thanks everybody for attending it. Have a great day.